Well, hello, it's Mr. Johnson. I want to give you a lesson here to help you with your factoring practice. We're practicing factoring where A is greater than 1. These are the hardest kind of factoring problems, and while guess and check will work some of the time, I hope to give you some structure and some skills that can help you factor any quadratic. And then this will lead to the quadratics we're going to do later this month, where you have quadratics you can't factor, and we'll use the same type of boxes and area method to complete the square. Which, if you're not familiar with that, that is where the quadratic formula comes from. And I'll tell you, I like completing the square more than the quadratic formula, and if you get good at this in the next few weeks, you do not need to memorize quadratic formula, which seems kind of strange. The quadratic formula is sometimes hard to remember. And so completing the square is more logical and will stick with you for longer, I believe. But let's jump right into our lesson for today in factoring where A is greater than 1. So I have some problems set up for us over here. Factoring where A is greater than 1. So here's our first problem, and there are the boxes. And when we do factoring with A greater than 1, you're going to immediately start drawing boxes like this. 4 boxes, and just so that you know, the word quadratic means 4, and you know, sometimes it seems strange, quadratics involve an exponent of 2, but quadratic really comes from the idea of area and 4 squares. Quad from 4 squares there. At least that was my impression. So let's when you think of quadratics, think of the boxes. Okay, first thing you want to do is look for GCF. If you can take out a GCF, your life will be easier. Do you see a GCF in these 3 terms? And I hope you see that it could be 2. So put a 2 in the front and pull it out. 6x squared plus 7x plus 2. And double check and make sure this is the equivalent to what we just had. Are these 2 things the same? And I think you'll see that they are. All right, so let's go ahead and clean this up just a little bit. And now we're going to factor this piece. There's our A, there's our B, and there's our C. And I call this the AC method. The AC method. So that means multiply A times C. In this case, 6 times 2 equals 12. We want to look for factors that add to 12. Add to 7, but multiply to be 12. So what are the factors of 12? You can write them out. 1 and 12, that doesn't work. You could do 2 and 6, that adds to 8. 3 and 4, well, that adds to 7. So there are our factors we want, the 3 and the 4. This is right. This one's not. This one's not. So 3 plus 4 is 7. So that's how we split up our 7x. Is going to be 3x in one box and 4x in another. And 6x squared is here, and our 2 is down here. And do you see that the contents of this box are the same as the contents of our parentheses? We're just splitting the 7x into 2 parts, 3x and 4x. And now what we do is we look for GCF. Not the same GCF as before, but the GCF of 6x squared and 4x, which happens to be 2x. You could also find the GCF this way, but you'll see it works out the same. 2x times 3x gives us 6x squared, and 2x times 2 gives us the 4x. And 3x times 1 gives us the 3x. And then we can say, yes, it does work, because 1 times 2 is 2. Now the dimensions here of our rectangle, this is really a rectangle. It's a rectangle. It'll be a square later. Right now it's really considered a rectangle because the dimensions are not the same. This is 2x plus 1. This is 3x plus 2. 3x plus 2. And 2x plus 1 multiplied by 2. Let's double check. Always check and see. Does this give us the 6x squared? Yes. Does this give us the C term of 2? Yes. Does 2 times 2x, which is 4x, and 3x times 1, does it give us the 7x? Yes. yes, yes, yes. So there's our answer. This here is equivalent to this here and equivalent to this here. They are all the same. This is called factored form. It's going to be really useful later on when we're trying to solve quadratics to be able to get to factored form. Okay? And just think about it. If we had this equal to 0, that's a complicated problem. But if we have it in factored form, we have ways of solving this. If it were in factored form, if this is equal to 0, this I can find answers from pretty quickly. It's when this piece equals 0 or this piece equals 0. That's why we learn this, okay? Let's do one more. A little harder. Can we factor this? A greater than 1. You could always try to do your factoring like this, right? And you could guess and check and see. We could do 5x and 2x and maybe plus 3 and minus 7 and just try things. And I respect students that just try, that just give it an idea and see if it works. Well, if you FOIL this out, it doesn't work. So let's use our AC method, A times C. In this case, that's 10 times negative 21. That's equal to negative 210. That is a big number. So, you know what I might do? I might look at the factors. We have 2 times 5 times 3 times 7. This is the prime factorization. We need a negative. That also equals negative 210. By looking at the individual factors, it may help me do a list here of factors, because I know it needs to add up to 1. Do you see why it has to add up to 1? Because it's 1x. There's a 1 right here. Okay? So let's think about how these numbers can group together. Maybe I'll try a slightly different color. I could do 2 times 5 and 3 times 7 and add them together. That would be 10 and 21. 1 would be negative. That does not equal 1. Can I do, so let's erase those. That doesn't work. What if I put together 5 and 3 and 2 and 7? That'll be 15 and 14. And 1's negative. If I have 15 and 14, and the 14's negative, will that add to positive 1? The answer is yes. So that just helped us identify how to get to that 1x. If I have 15x and negative 14x, they will add to positive 1. Here's my 10x squared. Here's my negative 21. Do you see how these two things are equivalent? Yeah, this is easier, I think, than just guess and check. Now let's fill in what the GCF is of this horizontal row. Do you guys see that it can be 5x, and we'd fill in 2x, and fill in 3, and say it out loud. What goes here? How about negative 7? And do they multiply to be negative 21? And you can say yes. So now the dimensions of my rectangle are 2x plus 3 times 5x minus 7. Don't really like my 5. Let's do it again. And can we FOIL it just to double check? Does this give us our 10x squared? Does the 3 and the negative 7 give our negative 21? Does the 3 and 5x give 15x minus 14x? And you should say, yes, it does. That's the factored form. These two things are equivalent. Let's do one last example. All right. Any GCF we can take out here? Don't think so. So what we're going to do, you could try guess and check, but I'm going to go to A times C, and that's 5 times 9 is 45. Everything is positive, so we're going to stay positive. I need two positive factors of 45 that add to 6. Excuse me, that shouldn't be 45. That should be, needs to add to 6. Well, that seems weird. Positive things, positive factors of 45 that add to 6. We'll just try 1 and 45. That certainly doesn't add to 6. 5 and 9 does that add to 6? Nope. 3 and 15, how could that add to 6? Nope. I think we've exhausted all the factors of 45, and they certainly can't add to 6. So if we can't do it, we call it prime. Just like if you had 37 as a number, what are the factors of 37? Just 1 and 37. So we call that prime. This one's also what we call prime. And we're pretty confident because we went through these steps here. Doing this kind of check would be harder. 5x and x. We could look for things like 3 and 3 or 9 and 1. You could try your guess and check, but that won't work that way either. So overall, hope this little tutorial will help. I hope you watch it again. I think this takes time to really develop this method. But like I said in the intro, the boxes are really going to be your friend. I hope you guys will give it a good effort and ask me questions, and I'm available for help and work by appointment. So be in touch. Thank you.